Okay, so another example. Okay, we have, we're gonna try to maximize the area of this shaded box. And the corner of the box is going to end up on this line segment. It's gonna be somewhere on that line, okay? So we need to think about what are we really doing? So this would be in X direction, okay? This would be a Y direction. There we're gonna have an X and a Y value because that point is going to be X, Y, okay? So what are we trying to maximize? A, which equals X times Y. This is what we're trying to maximize. So we need to get the area as a function of one variable so that then we can take a derivative with respect to that variable and set that derivative equal to 0. Okay? Well, now we have to think about this. What other property would that xy coordinate have? It would be a point on that line. So what we need to do is we need to find the equation of that line. Okay? So the first thing that we need to do to find the equation of the line, let's look for the slope. Remember, the slope is just rise over run, so we're taking y value, the difference of y is divided by the difference of x's. So, now, the slope of our line is going to be 1 minus 0 divided by 0 minus 2. Okay, so that's negative 1 divided by 2. All right. And remember, it's y equals mx plus b. So we got our m, and if we think about it, what's our b? Our b is the y-intercept, and we already know the y-intercept right there is going to be 1. So y is going to equal negative 1/2 x plus 1. All right. So we're going to plug that y into our area. So area is going to equal a little bit. All right, now x times negative 1/2 x plus 1. Okay? And so that would come out to being negative 1/2 x squared plus x. Okay. So we have the area as a function of one variable. So now what we're going to do is we're going to take that derivative with respect to that variable. So the derivative of a with respect to x, okay, so that negative 1/2 x squared, the x squared is going to become 2x and it's going to cancel out. That's going to be negative x plus 1, and we are going to set the derivative of the area with respect to x equal to 0. Okay? So what is that telling me? That's telling me that x is going to equal 1. Great. Right? And so y is going to equal negative 1/2 times 1 plus 1. All right? Well, negative 1/2 plus 1 is just going to be 1/2. Okay? Those are the dimensions that are going to maximize the area. And if you want to find the maximal area, all you have to do is multiply them together, and you're going to get 1/2. And now, whenever you do this problem, look at this picture and see if it actually makes sense. If you got like negative values or something, you know you did something wrong because that thing's obviously not negative. So look back at the picture and just make sure what you're doing makes sense.